And we're going to be using, once again, the Casio 115 ES Plus. I want to find the doubling time. That's a pretty quick move. Doubling time compounded continuously. That's important that it's continuous, and it's that. And notice the word double. So the calculator key is just going to be ln of 2, which is double, over the interest rate, which is 0.05. We just type that into the box over box key on the Casio. So it doesn't matter what mode you're in. Mode 1 is just good enough. So I hit the box over box key. I hit the ln button of 2 for double. You got to close the parentheses, down arrow, and then the 0.05 decimal, and that's going to give me, to the nearest tenth of a year, would be 13.9. Determine if it's 1-to-1. If it passes the vertical line test, it's a function. If it passes the vertical line test and the horizontal line test, it is a 1-to-1 function. So yes, this one is 1-to-1. It passes the vertical line test, so it is a function. But notice, in several spots, it fails the horizontal line test. So anything parabolic would not be a 1-to-1 function. It could be a function, but no, it is not 1-to-1. X squared, notice how it says x squared? Well, whatever this is here, it doesn't matter. The shape is going to be a parabola because it's x squared, and a parabola does not pass the horizontal line test. So no, it will not be a function. I want to know if the functions are inverses or not, so I'm going to take this first equation, y equals 5x minus 7, and I'm going to perform the inverse on it. So I'm going to flip-flop the x and y, so that's going to give me x equals 5y minus 7, and then I'm just going to go through the process and solve it for y. So I'm going to add 7 to both sides. That's going to give me x plus 7 equals 5y, and then I divide both sides by 5, and notice that gives me x plus 7 over 5, not x plus 5 over 7. So no, those are not inverses of one another. Same process over here. I'm going to rewrite this as x equals 2y minus 2. And I'm going to go through the process of solving it for y. So I'm going to add 2 to both sides. That's going to give me x plus 2 equals 2y. Notice I don't have a big fraction, so I'm going to divide everything by 2. And 1 over 2, that's 1/2. X, 2 divided by 2 is 1. So that there is the inverse. So yes, those are inverses of one another. They want to know if this is a 1-to-1. That is a line. 4x minus 7. It begins at -7, and it goes up 4 over 1. And it's a line. And a line passes the vertical line test and the horizontal line test. So yes, it is a 1-to-1 function, but then it wants me to find the equation for its inverse. So I'm just going to real quick rewrite it as x equals 4y minus 7. And I'm going to solve it for y. I'm going to add 7 to both sides. And that's going to give me x plus 7 equals 4y. Divide everything by 4. And notice I have a big fraction in my answers. So the answer is x plus 7 over 4. It's choice A. Not x minus 7, x plus 7. All they want me to do is plug the 2 in. So when I use the calculator, I'm going to type in parenthesis 1/6, and then the -2 is going to go up in the exponent, and the calculator will accept that pretty nicely. So I'm going to start off with the parentheses, then I'm going to hit the fraction bar, 1 on top, 6 on the bottom. Right arrow, close parentheses, x box to the -2. Just type it in like it looks, and my answer is 36. Just a simple calculator key in. This one, again, I'm going to type it in like it looks, but this time it's to the 5 halves. So I'm going to hit the box over box button a couple of times. So parentheses, box over box, 1 over 3. Right arrow, parentheses, x box, get that exponent going. Hit the box over box again, 5 over 2. Some people write it as 2.5, but you can type it in just like it's supposed to look. It equals 0.064. Notice that's one of my choices. 5 to the negative x. Well, 5 to the x would be growth. But because it's to the negative x, it's going to be decay. And it's going to be choice B, decay. Notice this one is a reflection, this one is a growth, this one is a growth, but it's a reflection growth. So it's going to be B. It's going to be B. 2 to the x, that would be growth. And then they have a -5. So all that means is wherever the growth is, according to the xy axis. So if I have a growth, it goes through 0, 1, I'm going to move it right 5. It's going to go right 5 if it's up there with the exponent. So that one doesn't go right, that one goes left. This one seems to go right 5, this one goes down 5. Number 11, notice that it's 2 to the x with the phase shift, 2 to the x. If I had an xy axis, it would grow. Now, all this does is it gets shifted opposite, right 5. When I put that -5 there, it's going to move that spot, right 5. So it's actually going to grow up to the right. And the only one that fits that description will be graph B. Notice this one is the normal graph. This one actually went left. This one actually went down, so it has to be choice B. Number 12, now I have 3x minus 3. 3 to the x is going to be growth. But the -3 not up in the exponent means it's going to shift that graph down 3 units. This one went up 3, so it can't be B. This one is actually a decay. It can't be that one. Another decay that went down 3, it wouldn't be that one. It would be this one, which is a growth that went down 3, so it has to be choice A. Number 13, this is a simple calculator key in, but first, you've got to rewrite it into this format. the log-base box format. Once you do that, once you write it into the log-base box format, it's a simple calculator key in. Let's take a look at it. So if I take this log-base box problem, and notice that the base is 1296, that's going to go down here in the base, so that's going to be 1296 down there, and then the 6 slides over. That's all I have to enter into the calculator. And real quick, the button that I use is this one right underneath the 1 button, and then I just type in the 1296 like it looks. 1296 in that spot. Right arrow, bring me up into the big box, put a 6. I'm going to get some weird fraction probably, and I get 1/4. So that would be choice D. Again, using the log-base box for number 14. I know it looks kind of harrowing. It's not that really that big of a deal though. Because all I have to do is rewrite it in an accurate form. The base is 1/3. That's going to go down in the base box, and the 27 slides over, and that's going to equal the exponent. So I'm just going to type that in again, using that same button. I'm going to hit the log base button. It's going to be a base of 1/3. Notice I use the box over box down there. Right arrow, I have to right arrow again to get it up in there, of 27. When I type that in, it gives me a nice answer of -3. Log base box button once again. So I'm going to bring my log base box template over. The base is going to be 2. The box in here is going to be 1/8, and that's going to equal negative x when I'm all said and done. So whatever this is, all I have to do is change the sign of it. So I'm going to hit my log base button again. On the base now is going to be 2. Right arrow, hit my box over box button. Type in the 1, down arrow over 8. Now my answer is going to be negative, or I'm going to change the sign of this. So I got -3, but it's actually negative x equals -3. So my answer is just going to be 3. Moving over here, solve this one. I'm going to do the same process with the log base button. But my answer isn't going to equal x. So log base 2 of 1/16, I'm going to type that in. So log base 2, well, that's already in there. I'm just going to back arrow and change that 8 to a 16. So when I type that in, that gives me -4. But it's the exponent equals -4. So I have to rewrite this as 5 minus 3x equals -4. And I'm going to go ahead and solve that. Divide the minus this side by 5. So that's going to give me -3x equals -9. And then when I divide both sides by -3, I get +3. Okay, number 17, to solve the equation, because it's multiple choice, what I'd like to do is I'd like to fill in that spot with this number and then this number and see if it actually equals 125. If it doesn't equal it for -625, then I'll try it for +625. So again, I'm going to go right to the calculator. I'm going to type in parentheses, that's important, parentheses, -625 to the 3/4. Notice I get an error message. So that means it can't be -625. I just back arrow into the original problem, and I'm going to change that to just 625 to the 3/4, and notice that works. And it actually equals the 125. So it can't be choice A, it has to be choice C. This one is a little tough. This one's a little tough. You can't take the -1 and keep plugging it in to each problem, or the -5/19 and plug it in each problem. But we discovered a method on the calculator to figure out how to answer these questions. You want to type it in just like it looks, 32 x box to the alpha red x minus 1. I'm going to right arrow. Now, I don't want to hit the equals button. You don't want to hit the equals button. What you want to do is hit the alpha red equals button to type in the equal symbol. Now that I have the equal symbol typed in, what I'm going to do is I'm going to equal it to 64 to the 4x. Alpha red x. Again, you don't want to hit the equal sign. You want to actually solve it. I want to solve it. So I'm going to hit shift solve, and that's over here. I hit shift solve. And somebody told me that, now it's going to ask me to guess. It says solve for x. So I'm not going to type in -1. I'm not going to type in -1. I'm going to type in -5/19. -5, whoops, I won't do it. Delete 5 divided by 19 and see if that comes out rapidly. Now it's thinking. Ooh, I think it worked. Let me see what that is. I'm going to write down -2.26315. I'm going to type that in the calculator. -5/19. Get the decimal equivalent. Ooh, that's it. So you can guess and test it using those choices when you do the guess part. So it would be -5/19. To do it by hand, I would have to rewrite this as a base 2. So you have to know that 32 is 2 to the 5th, and that 64 is 2 to the 6th. Then you would have to bring down that exponent of x minus 1, bring down that exponent of 4x, and then solve this top part of 5x minus 5 is equal to 24x. So I minus 5x on both sides. That's going to give me -5 equals 19x. And then when I divide both sides by 19, I get the exact answer the way that they wanted me to. You have to write it as a common base. Find the future value of that invested for 11 years at 6%, compounded semi-annually. This is a print problem. No I, sorry. So the P is the big amount. So it's going to be 45,689. The R, that's the 6%, but I have to write it as a decimal. The N is the number of times it's compounded. So semi-annually is 2. And the amount of years, the time, is 11. The template is this formula. They sometimes give it to you, they sometimes don't. 1 plus a fraction bar to some large exponent. And now, if we look at this, notice the 0.06 over 2 is going to go in this spot. And the 2 times 11 is going to go up here. I know it's 22, but if you don't know how to multiply, if those numbers are too difficult, you can just enter it in as such. Now, this is going to be a big, huge, large calculator key in. And remember, you have to type in the entire item of 45,689. So we're going to type in that entire thing, 45,689, open parentheses, 1, plus the fraction bar. On the top of the fraction bar, I'm going to put 0.06. I'm going to down arrow. I'm going to put 2. I'm going to right arrow, right parentheses, X box to the 22nd power. And it should land me really close to one of those choices, 87,544. Rounded to the nearest dollar, that would give me choice C, 87544. So that would give me choice C. Find the future value. So I'm going to pre-RNT it. The 29,000 goes over here, 29,034. The rate is 0.067. You have to be careful with that. Compounded quarterly, so n is going to equal 1/4 or 4. And the amount of time is for 2 years. So I'm going to come over and set up my template. 1 plus a fraction bar to some power. I'm going to take a look at that. That falls right into place, 0.067 over 4. And then I have to do 4 times 2 up here, which is 8. I'm going to type this entire entity into the calculator as quickly and accurately as I can. So this time it's 2934 parentheses 1 plus the fraction bar. The top is going to be 0.067. Down arrow, 4, right arrow, close parentheses, X box it. Don't forget to X box it. And then 4 times 2 or just 8 up in that exponent. And then boom, 335099, 3351 probably. Nope, they go right to the nearest penny. Right there at choice C again. Simple calculator key in, simple calculator key in. I'm going to type that in just like it looks on the calculator. Once again, using that log base button, which is right underneath the on button. So I hit that button, and then I type in the 6, and then the 36, and it generates the answer for me rapidly. It's just 2. They want me to rewrite this in logarithmic form, so that's going to be the base. That's going to be the base. So the base has to be 8, and I'm pretty much done. Now, if I look at this, I can do my little story. That log leg is going to kick that 8 over and push up that 1/3, and then that's going to give me 8 to the 1/3 equals 2. If I look at it in that format. 8 to the 1/3 equals 2. So it's going to be choice D. Let's see, the base is 25. So that log leg is going to kick that 25 over, and that 25 is going to push up the 1/2. That's going to give me 25 to the 1/2 is equal to what's left over, 5. So it's going to be choice C. And if you type that in, it'll equal 5 in the calculator. This one, I want to solve it. Nothing necessary to do other than type that in like it looks into the calculator. So again, I'm going to use that log base button. For the base, I'm going to place the 6. Right arrow, fraction bar, 1 over 36. Type it in just like it looks. It's really convenient, and that gives me -2 as my answer. Choice C. The leg is going to kick that 5 over and push them up. So 5 to the -3 is going to equal the x. So I need to type that into my normal exponential 5, x box to the -3. And that's going to give me 1 over 125. That's choice D. Number 26 is a graphical problem. So the question is, for me to graph log base 4 of x minus 3. So a log graph just creeps up along the x-axis like that. So it isn't going to be A, it isn't going to be B, it's either going to be C or D. But notice it's -3 and it's nested with those parentheses. That means it's going to go right 3. This graph down here went right 3. This graph here went down 3. So it's going to be choice C. Number 27, log base 2 of x plus 2. So let's make that a little bit bigger so we can see it. Log base 2 of x plus 2. If we enlarge that. Now, the normal log graph is going to look like this, and it's going to creep up along the x-axis, and it's going to go through 1, 0. So all this does is it takes that graph, and because it's not nested in parentheses like that one was, it's going to go up 2. Not the opposite. This one is the opposite when it's in the parentheses. When it's outside the parentheses, it's the same. It's going to go up 2. So that graph is actually going to sneak vertically up, and then actually be a little bit higher than the original. It can't be choice A. It can't be choice D. Notice this one went left 2. It doesn't creep along the vertical y-axis. This one creeps up along the vertical y-axis, and it actually looks like it went up 2. Choice C. 28. They want me to just graph log base 4 of x, log base 4 of x. It's just going to be normal, going up along the y-axis, going through 1, 0. Has to. Can't be A. It could be C. It can't be D. It could be B. But notice, B doesn't creep really close to the y-axis. It looks like it was moved over 1. So it has to be choice C. Properties of logarithms. If it's separated by a plus sign, you can't do it. It's going to be the original. This one, see, there's 1, 2, 3 items. So that means I have to write log base 2 3 times. Log, 3 times. Base 2, base 2, base 2, 17, m, n. Now I have to figure out what to do with the exponents. Nothing with the 17, m to the 1/2. That 1/2 is going to go out in front. The n is on the bottom. So if it's up top, it's going to be a positive. The m is up top, it's a positive. The n is on the bottom, it's a negative. I don't need the positive out front like that. So it has to end in a negative. A negative, not a division. You can't have a radical in the answer. The 1/2 is with the m, so it has to be choice A for this particular problem.